What I want to talk about this week is a couple of features that came in with C# version 8, which are range and index. Now, C# 8's been around for quite a while now. We're already on to C# 9, and the big feature in C# 8 was the idea of nullable references, which I did a couple of videos on quite a while ago. And because nullable references are such a big new idea, I kind of overlooked these other new features, which are really very useful as well. And this actually cropped up in another video I did a little while ago when I was talking about reflection, because I just used one of these ranges and quite a lot of people asked me to explain what that's all about. So I thought I'd go into that this week. And what I had something like this in that video on reflection was when I was putting together a CSV file, a comma separated value file. And so part of the code looked very much like this, where we have, in this case, just an array of strings with a load of names in them. And then I looped through and I just want to produce a single string where they are comma separated. So I append each name and then put comma space on the end, and that will give us this comma separated list. But the problem is that when I run that up, we can see that we get a trailing comma, which may not be too bad in a comma separated value file, but certainly in terms of display to a human reader, we don't really like having trailing commas. That's just how things work with English punctuation. And so we need to remove that last comma space. Now there's various ways we can do it, but the way I did it was to use a range. And I simply, on here, so there we've got the result as a string, I did square brackets and then ... hat 2. And if we now run that up, you can see we get exactly the same results, except we've now no longer got that comma space after the last name Gummo on there. And what we're saying here is I want to take the result, but then have a range which goes from the beginning. So I could have put a 0 in there, but if you put nothing at all, it's implicitly from the beginning. And then that hat means 2 from the end. So if I'd not put that in there, if I'd just put 0 ... 2, that would be 2 from the beginning. And so we'd only get the first couple of letters of the first name. So that's the really neat thing about it, that the hat means in from the end. Now, we could have done that before C# 8 in various ways. We would probably have done it something like this. We could have said result.substring, and then we want the substring from the beginning, so there's where the 0 goes, and then we need the length of the substring we're going to take. And in order to do that, we have to know the length of the entire string. So here we'd say result.length minus 2 to go 2 in from the end. And so that is the more old-fashioned way of doing it. It still achieves the same thing, but I think you'd agree that the syntax for this, just being able to say ... hat 2, is much, much neater once you get familiar with it. We can miss off the 0 at the beginning, and so just have the ... there. And also, if we wanted to go to the end, I could do something like, say, 5 ... and miss off the end, and so that would knock off the first 5 characters if that's what we wanted to do. It works on strings, as you can see. It also works on arrays. So we've got this array of names itself, and so on there, I could do something like have maybe names for 2. So from the second one to the third in from the end. And so now we'll see we just get a sub-range of those. So it applies to arrays and it applies to strings and some other things that we'll talk about in a little while. The other thing that you might think would be quite nice and is available is, given we've got this idea of in from the end, wouldn't it be good if we could also use that not as part of a range, but just as a single item? And we can, because that's where we get the idea of an index. So I could also, on here, do something like names, and then if we wanted the 5th in from the end, I could do hat 5 on there. And so now we can see we are getting the 5th one in from the end, which is why we've got the harpo in there. So, useful idea for the index. Obviously, you can just have a number, which would be the normal indexing we've had for years, or you can do indexing from the end, or you can do a range. And as you can probably guess, what a range really is just a pair of these indexes. And in fact, we can do a bit more on that. We could, for example, let's put in a couple of ints. So let's have an int x equals 2, and let's have an int y equals 5. and then we could put those in there as variables, and that would take us through from 2 to 5. And then what we could also do is obviously put the hat on that y, and that will give us 5 in from the end. But what you'd obviously really like to do is actually have that hat effectively in the variable y. So we could make the decision here as to whether we're going forwards or backwards. But as you'll see, if I put the hat on there, we start to get an error because hat 5 is not an integer. If we simply change that to a var, then it all works and it will run the same way. And we can see actually that y is of this type index. So system.index we've got in the .NET library, and that's what's being generated in C# by using the hat. I could do it in other ways. I could have actually said something like new index, and then if we look at the overload, it takes the value, so I can put in 5, and then it's got this optional bool from end, so that's the equivalent of the hat. So if I put true in there, then we can see that that will be the same as hat 5. And it's simply the language, the compiler, that allows us to put in hat 5, and that is read as a new index looking like that. We could also actually have the entire range as a variable. So I could just say var range equals 2 ... hat 5. And then I could in there put that range, and that will still do exactly the same sort of thing. And if we look at the type of that, we can see that that is of this other new type called, obviously enough, range. And again, I could have done this in a slightly more long-winded way. So I could say new and then range. And you won't be surprised to see that a range simply takes a pair of indices for the start and the end and puts them together. So again, I could have done 2, hat 5 there, but much simpler to do it with the built-in syntax. Once we've got something like a range, you can see that if I look at that, it's got the start and the end, which are the 2 indexes. If I look at, say, the start, so that's an index, you can see that it's got a value and it's got an is from end. So that's that Boolean flag we set up. And then you'll also see it's got this thing called get offset. And so basically, if I do get offset, I can pass in a length and it will give me back the offset that it needs to get at that length. So if I put a length of 10 in, say, and then let's just do a console write of that. Well, actually, because we're looking at the start, it's going to completely ignore that 10 because 2 is simply the offset from the start, doesn't matter about the length. But if I were to go to the end there, which remember is our hat 5, now it does the subtraction, and so we get 5 out of there. If I made that 12, we'd get 7 out of that, and so forth. And it's a pretty simple operation, but that's how it works under the covers. If you give it the length, it will give you the offset, and it's the same calculation we did in that substring for length minus 2. So those are the sort of features we've got, but really we don't use those very much. We just pass it into the square brackets and let the system get onto it. Now, I've said that this works for strings and it works for arrays, but what about other collections? So let's make a slight change here and let's change our names from an array of strings into a list of strings, just as an example of another collection. So pop that in there. And what you'll notice is down here, it's perfectly happy with us using an index, so that hat 5 will be 5 in from the end. But with a list, it doesn't like the idea of a range. And the reason for this is the way this was added to the language is done in such a way that it didn't require any rewriting of the existing collections, arrays, or lists, or anything like that. It builds itself upon things that are already there in certain collections, and the compiler just does a bit of work to convert things. And as I say in a moment, what we need for the ranges isn't actually available in the list. So let's suppose we were going to write our own class to do this, and then we'll see how that will work. So let's have a class myCollection, and I'll just base that on another collection. So I'll have a private and let's use list in there, private list of string, and we'll just call that values. And then because this is a collection, we ought to implement IEnumerable for string. And if you're not familiar with that, I did this in a video a long time ago. I'll put a link up to it. And then we can also just do that implement interface through underscore values. So it spots what to do there and just gives us those implementations. And so that's our basic string collection that we're writing for ourselves. If we put that down there, so replace that list of string with a new my collection, you'll notice it's not happy with the initialization here. And the reason it's not is because another thing you've got to do on a collection, if you want to be able to use this curly braces for the initialization, you've also got to give it an add method. So if I give this a public void add that takes a string value, and then all that obviously has to do is add that into our other values. And now you can see that everything's happy in terms of that initialization. So that's just a little trick. If you want to be able to use this syntax in your collection, make sure it's got an add as well as being IEnumerable. So nothing really new there, but we can still see, obviously enough, that we're not getting the range or the index working. And that's because it hasn't even got square brackets, it hasn't got an indexer. So what we need to do is write an indexer. In this case, it only needs to be read-only. You could put a setter on there as well, but let's keep it at the bare minimum. So I'm going to have a public string, and then remember the syntax for an indexer is simply the keyword this, and then in square brackets, let's just call that IDX, and then simple way to make this get only, we will simply now return underscore values, and a list also has its own indexer, so we just pass IDX in there. And having done that, you'll see it's still not happy with the range and the index. If I were to just go for names 5 in there, that would be okay, because obviously 5 is just an integer, and so it can go straight into IDX. But if you think about hat5, apart from any syntax rules, there is simply not enough information to know what hat5 means, because we know to work out what index hat5 is, we need to have the length for it to subtract off. And so the other thing we need to do is in here, it's got to have a public property called count. So if we give that a public property called count, and then defer that again just to values.count, then we can now see we've done the first part of it. We've got this hat5 working, so it can print out the 5th in from the end. So that's what you've basically got to have on whatever your collection is to make it work with an index. You've got to have an ordinary indexer taking integer, and then you've got to have a property called actually count or length. You can call it either of those, and you can still see it works there, because things like a list have a count, whereas things like an array and a string have a length. So because they wanted to do this implementation without changing anything, it will work on either of those. But it's a bit more consistent because this is our own collection to call that one count as well. And that's why we saw that the index works with a list, because list does have a count and an indexer, so that's all working fine. If you want to use ranges, you've got to do a little bit more. So what you've also got to put into your system is you've got to give it a method called slice. And so we'll have a public method called slice. We'll get it to return a list of string. We could actually have made it return another my collection, but that's just overcomplicating things. And then we have this thing called slice, and that needs to take 2 parameters, a start and a length. And then all that has to do is give us back a slice of our collection. You can see, although I haven't finished it off, it's now already happy with our range. So all I need to do here is something like this. Let's take our values and then do this in the more old-fashioned way. So to do that, I would do a skip. So I'll use link here. So skip start. So we move along that far. And then we can do a take length And then all we've got to remember to do is turn that back into a list. So dot to list. And so now you can see that that is perfectly happy. It's got the square brackets, the indexer that will take a range and that will take an index. And if we run that up, we'll see we're getting the correct results. We've got the Harriet, Charlotte, and everything's working fine. And so that's really it. And the point of it is, though, all of this work is actually done by the compiler. So we've just got these straightforward methods, properties, indexer on there. And when the compiler sees a range that we're trying to pass in, it actually does all the work. So it calls the slice, calls the count, subtracts 5 from the count, and eventually that's everything that gets passed in there. But that's why we didn't have the range working on a list, because although a list has a count and an indexer, a list does not have a slice, whereas arrays and strings do have a slice, have done since the beginning of C# and .NET, and that's why this system is designed in that way. So it could just hook into what was already there, but unfortunately, because a list doesn't have a slice, it can't hook into it on that, but we can write our own collections and have that in there. But really, writing our own collections, we've talked about before, it's not something you want to do that often. The real neatness of this is just being able to put together those ranges, those indices in from the end. It just makes the code much, much tidier. So I hope you found that helpful. It is going back a bit to C#8 because we're already on C#9, but it's a worthwhile thing to look at. So if you enjoyed it, do click like, do subscribe, and I'll see you next time.